Hello, physics students. This is Dr. Brinzy here. The reason I'm making this video is because I noticed that a lot of you were struggling with problem number 2 in the homework, and I thought I'd provide a little bit of hints and assistance by giving you a similar problem. So what I have over here on the left is I have two 50-kilogram boxes that are being pushed with a force of 300 newtons, okay? And I'm going to ask myself, okay, I'm going to ask myself, what is the force that box A, we'll call this box A, is pushing on box B, and likewise, what is the force that box B is pushing on box A? Now, if you were doing this in real life, you would probably expect, if you were pushing box A and box B was behind it, that box A and box B would accelerate at the same rate. Just as if we had a 100 kilogram single box that we were pushing on with the same force. And if we were pushing on that with the same force, then we would expect an acceleration of 3 meters per second squared. So let's indeed see if that is what we get here, that our acceleration is going to be 3 meters per second squared. Now, I think some of the confusion that comes through these two-body problems is the fact that we're not actually used to making two different free body diagrams. So let's make a free body diagram for force A, and let's make a free body diagram for force B. So I have, on force A, we have this pushing force of 300 newtons right here, and that is going in this direction. I'll just label that as 300. And then also we have the force of box B pushing on box A. So I'm just going to call this FB. It's the normal force that box A experiences from box B. Now let's go on to box B here. Okay, now box B, the only force it experiences is the force, the normal force, that box A is exerting on it. So we would say that this is F sub A. Okay, and that's the only force that's being exerted on box B, as long as we can assume that we are on a frictionless surface, which I'm going to assume. Okay, now Newton's third law states that this force and this force have to have the same magnitude, but opposite directions. Okay, so I can say that FB equals FA. But since they're in opposite directions, actually what I should have done, I forgot to put my minus sign right there to indicate that's in the negative direction. So I can rewrite this as 300 newtons in this direction, and I can write this as F sub A, and we'll put a minus sign in front of it. Okay? So that's what Newton's third law allows me to do. Now, why do I care about that? Okay, so what I would do then is let's go ahead and set up two separate situations of Newton's second law, one for box A and the other for box B. Okay. All right. Now, the only force that box B is experiencing, that net force, is only the force of box A. So FA equals the mass of that box times its acceleration. All right. And the net force of box A is this force plus that force, so we have negative FA plus 300 equals its mass times its acceleration. Okay. Now, we can assume that these accelerations are the same because we're going to say that box A and box B are sliding together. If this weren't true, then it'd be pretty hard to figure, it'd be pretty hard to think that box A would accelerate more than box B, right? But it would be entirely possible, maybe, that box B is accelerating more than box A. But let's assume that they stick together and that they have the same motion, so therefore they have the same acceleration. So these two variables are actually going to be the same. So let's find out what that acceleration might be. Okay, so FA over here for box B, that is equal to the mass of box B, which is 50 kilograms, times the acceleration that both boxes have. All right, so I can go ahead and take this and replace this with 50 times A. So I have negative 50 times A plus 30 equals the mass of box A, which is also 50 kilograms, times A. All right, now let's get all my A terms over to one side. Add 50A to both sides, plus 50A. And it turns out that 30 equals 100A. And let's see here. Oh, why did I put 30? It actually should be 300, shouldn't it? I don't know why the 30 is in there. It's 300, 300, 300, and 300. Okay, there we go. That looks better because now my acceleration A, oops, not big A, little a. Little a, boy, that looks terrible. I'm going to move it over here. Let's move it all the way over. All right, there we go. Little a equals 3 meters per second squared. And that is the same acceleration that we got up here in this situation where we had a single 100 kilogram box. All right, now, a lot of us were thinking that when we first set up this problem that the force that box A exerts on box B is 300 newtons. Let's think that through and figure out why that can't be correct. Well, if I push on this box with 300 newtons, it is also, and you're saying it also pushes on this box with 300 newtons, well, by Newton's third law, that means that box B has to push back on box A with 300 newtons. So this would be 300 newtons, and this would be 300 newtons in the opposite direction. So what would be my net force? Well, it would be 300 minus 300, which is 0, which means my acceleration has to be 0. Now wait a minute. Haven't you ever pushed a couple of boxes across a table before? I mean, maybe not 50 kilograms apiece, but you've pushed boxes across tables. And it's certainly not true that if you start pushing on this box that they experience no acceleration, right? So we know that that can't be true, that this transfers 300, well, I should put it this way, that box A exerts 300 newtons on box B, and box B exerts 300 newtons on box A. So how much force does it exert on box A? Well, let's find out. Okay. So actually all I have to do is just take 3 times 50, right? And I get the force due to box A on box B is 150 newtons. So if we push with 300 newtons, it's only going to transfer 150 newtons from box A to box B. So this is only pushing on this box with 150 newtons. Okay, and that allows us to actually accelerate both the boxes in the right-hand direction. All right, so the whole force thing was a little bit counterintuitive, right? But that's how Newton's third law works. And it's really interesting now that you've actually seen it at work. So hopefully this will help you with problem number 2. You should probably do a similar setup where you're have both free body diagrams, and then you also have Newton's second law for both box A and box B, and that'll help you figure out what the acceleration has to be on both the boxes, and also what the force that box A exerts on box B, and vice versa. All right, physics students, I hope you have a good evening, and I hope this helps you out. Look forward to seeing you soon. Bye.